Good evening, good morning, good afternoon, you eCognition fans. This is Keith Peterson, the eCognition product manager, talking to you live from Munich, Germany tonight. I hope we have a good presentation in store for you. We are pretty excited here because we just released eCognition 9.4 on Monday, and it has a lot of nice little features in it, and we are going to introduce these to you to jumpstart your use of these new tools. So as we get into this webinar, we will do a live demonstration, and then we'll jump back into a presentation of a few other new things we've been working on beyond just the software. So just bear with us. I would like to say, before we get started, everybody's in listen-only mode. That is our intention. If you would like to chat with us, you can do this via the question field in the GoToWebinar. I have the pleasure of having one of our technical support engineers on the line with me tonight, Matthias Stengel, and he will help me with questions in the background. So Matthias, if you want to just say hello to our users and fans out there, this is the chance.
All right, hello everyone, and welcome also from my side. Please do not hesitate to ask questions. I'm going to try to answer all of them in the question field. So, and if Keith cannot answer them live, we after the webinar, we're going to try to answer all of your questions. So please go ahead, do not hesitate to ask us.
All right, very good. Another piece of housekeeping I just want to get out of the way now is that, yes, this webinar is being recorded. So if you miss something, you may just have to jump off your computer for a minute. We understand. You can access the recording after the webinar has been concluded and go back and rewind to all your favorite highlights and clips that we've shown here. So please feel free to do so. And now I hope you can sit back and relax while we present what is new in eCognition 9.4. First of all, an introduction. There may be some people out there that are completely new to eCognition to begin with. So what is the Trimble eCognition software? Well, we are focusing on the eCognition suite software today. And we provide an advanced analysis software. Don't get scared of the word advanced. Right off the bat, we have been really pushing to make it easier, which we'll get into in a few moments. But this software is for the development of workflows for image analysis, data analysis workflows for doing feature extraction, change detection, turning our geospatial data into geospatial information. So we're taking those beautiful data products that are constantly being collected via satellite, UAV, aerial systems. That data could be an image data set, it could be an elevation data set, also rasterized or in a point cloud format. We can combine those with GIS data products, shape files, file geodatabase, all within a single project environment within eCognition. And using these, we can extract land cover, impervious surface maps, and even go after identifying individual objects in the landscape. So maybe we were looking at individual trees. So we are extracting information from these great data products that we have available to us. The eCognition suite is composed of three components. They can be used as standalone or in combination to cover some of the most challenging fully automatic or semi-automatic production workflows. The real heart of the software is our eCognition developer package. As the name implies, this is the development and analysis environment for creating these workflows to extract features from our images and point clouds. Secondly, we also have an eCognition Architect. This provides a type of front-end application, so we can take that eCognition rule set created in Developer, and we can wrap a graphical user interface around it for, say, people that should be devoted to production and not get bogged down in the nitty-gritty functionality of rule set creation and execution. Finally, we have an eCognition server, and this is a batch processing environment for big jobs or very repetitive jobs. Here we can send multiple jobs, so batch processing with at least one server engine, or parallel processing if we have more than one engine, and we can get these jobs done, spread them out into various server environments. eCognition Architect can also be tied into the use of server. So these production jobs can obviously be distributed onto a server grid or network as is needed. And of course, the eCognition developer will also support the use of eCognition server for running these jobs. eCognition server is not required by any means to execute jobs in developer or architect, but it provides the batch processing capabilities. So if you have a lot of image tiles, for example, you can compile these in a workspace, send that whole workspace package off, and let it run overnight or over a weekend, and then come back when it's completed. So that's just an overview of what it makes up the eCognition suite. Today, we're really going to be focusing on eCognition Developer. And again, this is for the extraction of information from our data products, but we can also use it to update existing information. So some of those cadastral data sets that just not being updated fast enough based on the amount of geo data that we have available to us. You know, if we think about some of these satellite constellations out there, we're getting new imagery on a daily basis, and we can take existing data sets and update them based on new imagery or new point cloud information within eCognition. Right, I already touched on some of the unique features, but just to visualize this, what we're talking about, we can combine, we call this data fusion within eCognition, and within these project environments, we have the capability of combining our raster data with vector data sets, with point cloud data sets, if they are available. By no means is it required, but by interacting between these different data sets, how these data sets can communicate with one another through various features within eCognition, we can lead to a more robust and an improved classification result or a better feature extraction result. And this is a real strong point within eCognition. That being said, I'll get right into why most of us are here this evening, or if any of you are joining from North America at the beginning of your day, is to highlight our latest release of eCognition Suite 9.4. Now, within 9.4, we've been busy working on several things. We have three key highlights here. First of all, we really wanted to focus on improving some of our user interface efficiency. And by this, I mean adding a new view settings dialog for easy data management and faster data visualization. Many of you are probably scratching your heads. Don't worry, we will show this in action in a few moments. Additionally, we have added search capabilities to the feature view, as well as any menus within eCognition that reference features that will allow our users to quickly locate those features, less clicking in this case. And we've also added an HTML-based help, so all of the help documentation can be searched at one time. You no longer have to open individual PDF documents and search in the reference book. If you didn't find it there, open up the user guide. You can do a universal search across all of our documentation. For those of you working in an offline environment, don't worry, the documentation in PDF format is still installed with your software and can be reached in those cases. We also focused on new algorithms for what we're calling enhanced usability. So we saw there are a number of operations, very common operations within remote sensing or within feature extraction workflows that we wanted to streamline. We wanted to make it easier for our users to get to their goal, less construction of rule set here. So we're calling these out-of-the-box algorithms. So we've created some algorithms for index layer, common index layer calculations. So your NDVIs, NDWIs, you can do this without then having to physically type in those formulas. And we will also show some of this later. In addition, we've added several segmentation algorithms to 9.4 that will make life much easier when you're working with vector data sets. So a vector-based segmentation algorithm is available. Again, we will also show this, as well as a new algorithm looking at the segmentation based on standard deviation layers. Very, very nice algorithm when working with elevation data sets. as we continue to work with more and more point cloud data within eCognition, we found that there was also room to improve and advance our 3D visualization capabilities. And right now we've added the support of 3D vectors into the 3D point cloud viewer to really give users the full interpretation of their spatial data. And it's a great tool. We've really been using it on some of our internal projects as a major time saver in terms of understanding how certain point cloud driven analytics are working, or in some cases not working as maybe the user wanted them to. So these are our real highlights within version 4. Some details here, just a preview of the new view setting and source view dialogues. Like I said, it's a centralized data visualization and management dialogue. On top of that, we've added the support of drag and drop to create projects very quickly within eCognition, so we can drag and drop data into our viewer. We can drag and drop workspaces, projects, and rule set to really accelerate rule set development and at least project setup within eCognition. And then, like I said, the feature view search functionality is also available here. These new algorithms for enhanced usability, again, we wanted to eliminate some of the workarounds that were there, so common index layer calculations, NDSMs, vector-based segmentations, and then this standard deviation split segmentation is actually a repackaging of an algorithm that has been available for a long time within the eCognition community, a customized algorithm, but making it more present within the software. So really trying to avoid some of that head scratching and running with your head up against the wall, getting you to your goal of feature extraction quicker. Within the 3D visualization, here is a preview of some great work that our team has done looking at some of these 3D vectors within the point cloud. As you can see, we can operate with points, polygons, and lines all within in the 3D viewer. So to summarize what we've been doing over the past months here on eCognition 9.4 is to add tools to better support what I call daily development tasks. The centralized data visualization, management, and of course then the 3D viewing to get these common feature extraction operations make life easier for our users in general. That being said, just for those of you that maybe missed the announcement, eCognition 9.4, it released on the 12th of November, and all users who have a valid maintenance contract were notified of this and were given access to the software in the download area. Here are those links. The free trial for version 9.4 is also available on our website. And also a plug here for the eCognition community. You also find material here within the community. So before we get into the live demonstration, are there any questions out there that have come up during this presentation? And Matthias, hand over to you.
There actually just popped up one question regarding if eCognition 9.4 supports Spanish language.
Well, if you're talking about the actual graphical user interface, no, the graphical user interface remains available in English. But of course, you can add all your layer aliases and if you want to change any of the labeling, customized labeling of algorithms, you are certainly free to type in Spanish. The only thing I would advise is to not use any of those accent symbols and things like that when doing naming. But the software is available in English, and this is not for any particular reason other than the fact that at the moment the bulk of scientific research in the field of remote sensing is also in English, but we have been looking into this issue, and we may address it in a future version. So thank you for that question.
So yeah, that was the only question, Keith. So I think you can go ahead with the demo, and maybe some more questions will pop up.
All right, then let's get into the live demonstration. Jump out of the PowerPoint here. And now we're in eCognition Developer. When you open the software, this is the environment that you will initially see. We've made some changes to this view setting 1, so that traditional view setting for doing your, if we see here, load and manage data rules view setting. The first thing I'm going to do is, because I'm not going to be working in creating workspaces, I'm just going to pin that off to the side so we have a little bit more view space available. New users, this will all be new to you, but any experienced users, you'll also see now this new dialog here called View Settings, and I will explain how this works in just a few moments. So as I mentioned in the presentation, when we create a project, we can now simply drag and drop data right from our file explorer. So here I have some data queued up for this demonstration. I have a point cloud, a raster file, and some vector data. So I'm just gonna go in and grab this image. As you can see, I can just drag and drop right into my display, and the image will pop up. We also see that we have in the view settings some controls that are very similar to how we interact in a GIS, except for we need a little bit more functionality than some of the standard GIS display functions here. So you can see automatically displaying all the bands that are available. We can, of course, go in and turn these off right from here. No longer have to go into individual dialogues and open, say, that image layer mixing, and then point cloud layer mixing and vector layer mixing. So we've put everything into a single environment here. That being said, we can now come back and grab, say, that point cloud layer, LAS file here, because the LAS, we do some conversions behind the scene. It can take a few moments to load depending on the size. But what we will notice is that it is also available directly within the view settings, as will be the vector files here. So that's the next one I'm going to grab is my vector data. I'm just going to grab my shape file, drop it in here. So now if I come back into my menu, I see here I have my image layers, my point clouds, and my vector files. So by default, we immediately just show the image layers, but I can certainly go in and turn on a vector layer here, make that outline a little more aggressive. So we can see here we have some building footprints for this particular data set, and these can simply be displayed here from the view settings dialog. I can also easily control my outline width, transparency, and any of the fill colors that I may want to apply here. If I had multiple vector files, of course, I can control the outline width and display individually here, and I can also use a universal control in this lower part of the window that it would increase the outline width for all vector files that have been input. Simply turn these off here. Here you can control turning on and off individual layers, or I can simply click here to turn off all vector layers within a project. The same is true for point clouds. So if I come in to my point clouds section, I can turn on a particular layer here in the lower section. I get details, some detailed parameters and settings about that are very specific just to point clouds. So I can come in, turn on this point cloud layer. It will be displayed on top of my image layer here. I can turn this off to avoid some of the confusion in the background. And by default, we are displaying this render mode by height. And again, all the rendering functionality that was once in the point cloud layer mixing dialog is also available here, but from a single click window. It's very nice to have. And we, of course, we can display our vector files in addition to our point cloud. And we can also access our 3D subset selection from the view setting dialog. So we can come in, zoom into an area here. This will then launch that view setting dialog for us. I can come into this window. We can increase the rendering size, or the point size that we're rendering. Zoom in, and I can see how these work with the vector objects here. And this particular shapefile does not contain any 3D information, so the vectors are being drawn here on the ground level of this point cloud. Now, I also mentioned that there is a view, a source view dialog. By default, it's not immediately in this opened in the window, but we can come up to our view menu, click on source view. This is then added, and here we get again very similar to the type of environment we're working in a GIS. I can get information on my input data, so I can see the file path. I can look at individual layers that are available here. I can come in, I can remove any layers that I maybe don't need in a project, and I get information about the project itself, so I can see its coordinate systems, what units we're working in, the resolution, and then also the physical size of this input data set. More importantly, I can come in, and here I can actually control or access my layer alias capability. So I can come right in and start renaming my layer aliases directly here, and just blue, hit enter, and what you'll notice is that it immediately is altered here in my view settings dialog. Another highlight, anybody who's been using eCognition for a while, if you created a project, once you created a project, you couldn't go back and shift the order of layers. Now I can do this at any time. I can simply drag and drop within my source view the order, and you'll see it's also these changes are reflected in my view setting dialog here. So important functionality, putting it in an area that's very easy to reach for users, that give them great information on their particular project input data, as well as making rule set development, at least the initial rule set development and data exploration, much easier for the user from this sort of GIS-like view setting dialog to control how we interact with the data. So Matthias, have any more questions flowed in while I've demonstrated these view setting windows?
There was a overall question if there's any college book about eCognition. I think that question is aiming on additional material and resources, but I guess we're going to have a few slides at the end of the webinar, right? About resources.
Yes, we're going to include some sources on what another big area that we've invested time in over the last year on eCognition resources after we run through this demonstration. In terms of college textbooks, I'm not aware of any eCognition specific textbooks that may be out there. I do know there are some general object-based image analysis textbooks available. I believe one of the famous ones would be from Thomas Blaschke at the University of Salzburg. So that's definitely somewhere you can get started on understanding object-based image analysis techniques and theory. But for eCognition, we'll look at some of the great resources that are available to you in a few moments.
Yeah. That's already it, Keith. I think you can go ahead with the presentation.
Excellent. So I've just shifted into a slightly different project that I've prepared for the demonstration. As you can see here, layer aliases have already been established. Again, you can do this through that source view window. Layers have been reordered here. The only thing that's really missing now is a rule set. So, like I mentioned, we can also take those rule set files. So in this case, it's a DCP file. Just drag and drop it right into our process tree here, where the rule set can be created, launched, and managed. So we'll step through this and display a few things. Just some housekeeping here. I'll run through and set our rule set options. In the first section we see here, obviously the name of the rule set forest classification gives away what we're going to do here. We're going to try and classify this forest area. We're going to do some pre-processing right off the bat. We're taking our point cloud data. So here I'm working with our rasterized point cloud. I'm taking features out of our point cloud data, in this case, simply the z values, maximum z coordinates, and I'm going to turn them into what we call a DSM layer, and then simply applying a median filter here to do some smoothing. So we have then a DSM available to us as a raster layer in this particular project. So you'll notice too, when we create any temporary layers within eCognition, they are also added to this view setting automatically. We can add a little bit more organization to this view setting by coming on to this button here, which will toggle the grouping of files to display. So if I turn this on, you'll see now that I'm working on different groups. And here I have a group called temporary. So any temporary raster files that we create within eCognition will be stored in this particular piece here. Why is there one also called point cloud LAS? Point cloud LAS is actually a point cloud file, but as many of you may know, when we bring in point cloud files, they are initially rasterized based on intensity values if it's available. So we can just turn that completely off. It is grayed out. So we can take a look at this DSM here that we've created and extracted from our LiDAR data. Looks pretty nice. And we will obviously use this within our analysis. So one of the first things I want to demonstrate here is that we have some of these new segmentation algorithms. The first one is called a vector-based segmentation. How does this work? Well, essentially it replaces that old workaround of chessboard segmentation with some abstract chessboard size, commonly 99999, to do almost to cut out and convert our vector objects into image objects. So I'm just defining here the vector object to be used, and these are the ones I would like to convert to my image objects, and I will create a level called level 1, excuse me. We do this, runs quickly, and we can come in now and find these image objects. If I zoom in, see them better, is now here is an image object that corresponds to my vector layer. If we turn this on, we can see that this is the image object corresponding to the vector object. The other new segmentation algorithm that I mentioned earlier was this standard deviation split segmentation. And this is a great segmentation approach for looking at certain elevation data sets. And that's what I'm going to run here. Is I'm simply going to, here again, what level, image object level should my objects be stored in. And I can define a single image layer for which the standard deviation layer will be generated in the background. And I will step through this and create objects that correspond to the sort of the homogeneity of the values within my standard deviation algorithm. This may take a few moments to run. While it's doing that, are there any more questions that have popped up in the meantime?
Keith, no, there are more general questions. One is more about if we have an educational program for universities for eCognition.
I can only assume you're talking maybe about special pricing that for educational customers, and there are discounts for educational customers available. In terms of us interacting directly with universities, we do have partnerships. Our Centers of Excellence or our Trimble Innovation Program, we partner with several universities around the world in providing feedback and working with them in terms of not only looking at future eCognition technology, but they're also a great source of feedback on how the software is working and certain things can be implemented, and also working with them strongly to solidify the education of eCognition at the university level. So I believe on our website you will find a section on the Trimble Innovation Program, and you'll see the various partner universities listed here. In fact, the data I'm using today was provided by one of our partner universities, the University of Vermont. So if Jarlath is listening tonight and his colleague Noah, thank you very much for providing this great data set from the state of Vermont. So as you can see there, we do have a good working relationship with universities. Any other general questions while this runs? It shouldn't be running too much longer.
One question just popped up. If you could explain a little bit more about this standard deviation split segmentation that you're just showing at the moment.
Sure, I think it will become apparent when we're here, but what we do is for the layer that is defined in the algorithm, a standard deviation calculation is run, and eCognition will split the image into image objects based on the values of that standard deviation layer for the layer that was defined here. So in this case, I calculate standard deviation based on the DSM, and I will split objects based on that criteria. So based on my stepping size, we'll go through and eCognition will find these objects of similar standard deviation and create objects for them. So like I said, it works very well on elevation data. As you can see, I did not choose to use my vector for the building, but because this has a different standard deviation in the step size to these other surrounding areas, we can quickly use this to get some object primitives, as we call them, for some things like buildings or forested areas. As you can see here, some of the elevated objects. Also here, taking into account slight elevation changes in this particular field. And we have nice homogeneous objects which are a good starting point when doing classifications that may involve the use of elevation data. So that, again, is one of the new segmentation algorithms available here in eCognition, and is very useful, again, if we're looking at our DTMs, our DSMs, NDSM type information, but you can certainly apply it to other optical based products as well. So now, just remove this. We'll go back into working on our optical data here. Just going to run, say, your standard multi-resolution segmentation here. Again, any new users, we've now use up to 8 cores when the multi-resolution segmentation algorithm is running, just to accelerate this. Create some nice image objects here that we'll use then for the remainder of our analysis. So within the classification, first thing we're going to do is go after elevated objects. We're looking for forest. And I not only have optical data available to me, but I also have my elevation data available. And if I think of how we can describe a forest in the broadest terms possible for a computer, it's essentially elevated vegetation. So the first thing I'm doing here is just based on my DSM data, I'm going to classify anything higher than 2 meters or higher than equal to 2 meters in height. And I'm going to call this elevated. So if I turn on then my classification view here, we can see how this has worked here. So we have some great image objects that we've initially classified. What we see though is we also have some of these buildings in the elevated class. Why was this particular building missed? Well, if we actually take a look at our elevation data set, you will see that this particular building, I'll turn this off again, is more recent than our LiDAR data. So it is missing from the elevation data set, hence we missed it based on this simple call of just classifying our elevated areas based purely on the DSM. So next, I want to look at forest. And what is unique about forest? Well, or unique about vegetation in general from a remote sensing perspective is that we can use an index like NDVI, that a normalized differential vegetation index, to describe this. And like I said, we've made things easier for our users by giving them an out-of-the-box algorithm to do index layer calculations. And one of these, of course, is the NDVI, which is, you can see here, for people that maybe not too familiar with NDVI, giving them a hint that it's a vegetation index here. And you can see all the user now has to do is select which layer of their input layer corresponds to the red layer and which of them to the near infrared layer. In this case, we just used red and NIR as our abbreviations. Other than the NDVI, what is available here, we offer at the moment NDWI, so the water index. We have an NDSI. There are 2 NDSIs out there, folks. So this is the soil index. And we also offer the NBR, that's the normalized burn ratio. This is a very effective index when looking at burned area, so people out in California may be listening in, all those wildfires that are going on now. This is a great tool in identifying those from remote sensing data. You'll notice that when I change my index, I will also change certain parameters for input data. So then NBR, for example, requires that shortwave near infrared band to run effectively, or to run correctly. Another nice aspect of this this prepackaged algorithm is that we can automatically account for those undefined values that would normally, by doing pure band math or layer arithmetics, as we call it in eCognition, those could lead to some real wild values if you have these no data areas there that will then impact the stretch display within eCognition. Here, the user can input undefined value, and this will then remove the need for adjusting some of those parameters. But you also see the rest of the parameters here. We even have a default name that is suggested based on what algorithm, or what mode or index you select here. You can also come in and adjust this if you don't want to call it NDVI. So let's execute this. As you'll see, it is also a temporary layer within eCognition, so we can come in, turn this layer on, and take a look at it. You can see, yes, Vermont has a lot of vegetation, very high NDVIs throughout this image, but we can see here our houses, for example, obviously lower values, these roads in the negative area as well. So we can use this then to discriminate between elevated objects and elevated vegetated objects. Jump back to our image and our classification view here. And the next step, we're now going to apply this NDVI as a class description. So we're taking that elevated class, only looking at the objects classified as elevation. Now we're saying if one of these elevated objects also has a high NDVI, in this case higher than a 0.01, we are going to call it forest. And we can see how this works. Zoom in here. I can see that this object here is still in my elevated class, whereas these objects here, elevated vegetation, have been classified nicely as forest. We can also use information in our point cloud directly when looking at a classification or a class description. So in this case, looking at the number of returns, or in this case, the average number of returns from our point cloud. And we can also use this on the elevated. If there are a few that were misclassified, we can also add these to that forest classification based on parameters coming directly from our point cloud and not rely solely on a rasterized point cloud products. The next thing we're doing here is we're just looking at now the context parameters. Another real strength of eCognition and working with image objects is not only can I look at spectral values or point cloud values, but I can also look at how image objects relate to other image objects. So we're looking at here the relative border in combination with number of returns in the elevated class. Again, trying to work out some of those small pieces that maybe didn't initially get into our forest class. And finally, nothing new in this area, but we're running just some of our refinement or object reshaping parameters here, merging our different objects. So we still have lots of different image objects here, applying some merges to, as you can see, this is essentially like a class-based dissolved out of GIS. And then we can take and we can reshape these. So applying just some image object based resize or pixel-based resizing here. If you're interested in these various refinement techniques, that was our last webinar that we did. So you can look at that in the Geospatial webinar archive, and we go in there into detail on how these different reshaping algorithms can be utilized within eCognition. So I won't go into depth here. That is available in the earlier exercise. So here, again, just doing some general improved classification. So we're going back and we're just now adapting this, looking, removing some of the areas that are below certain minimum mapping units and things of that nature to get a cleaner classification here, fill in some of those gaps that could have been caused in the forest canopy. And voila, we have this nice classification result here. But the stress really being in this webinar on the new tools, not only to visualize, but those new segmentation and techniques and new out-of-the-box algorithms for doing indice calculation, and how you can really work around and develop rule sets quicker, more efficiently with such tools. So that ends our demonstration. Are there any questions before I jump back into our PowerPoint and discuss the resources that we've also been working on over the last year or so?
There are actually two questions. The first one is fairly long and complicated, but I try to break it down. So if you have any suggestions how to address threshold values from image to image. For example, if you have one image, the NDVI threshold might be 0.01, and another image taken in the same region, you might need to adjust that threshold to 0.5 or something to get the same result. So I think the final question is if it's possible for eCognition to suggest a threshold for the NDVI from image to image and region to region.
One thing to think about when working on transferability, as we call it, taking taking your rule set and applying it to other images, maybe collected at different time periods, is starting to, instead of working with a set threshold, is to then working with what we call variables within eCognition, where this threshold value can, as the name implies, vary based on parameters that the user defines in their rule set. So maybe, for example, you have an image collected in a leaf on situation and a leaf off situation, and we can read the dates. If the date is in, say, that image header, for example, just thinking off the top of my head, we can grab that information out of the image header and then define whether this is a leaf on, leaf off scene based on that type of variable situation. We could change the threshold value, whether it's going to be NDVI or something else, and look at that. We can also look at various scene features. So if I come into my feature view here, there are features that apply to the entire scene here. So you have some of these scene related. You can then look at these values to determine whether you may need to adjust those variables that you're using for thresholds within the rule set. That's it could go on and on about this, but for sake of time, that would be one way of approaching this transferability issue, is instead of working with set thresholds, is changing those threshold parameters to a variable that you can base off various other features, such as scene features or regional features within your particular project.
Okay, good, Keith. You can just leave the feature view open, because the next question is if you could show this search functionality in the feature view that you mentioned in the presentation.
Sure. So you see now in the feature view, there is this field up here, search feature. So maybe I'm looking for a near infrared feature. I can simply type NIR. That's one thing you have to know, is how I use my layer aliases, and I can quickly see now here are different features that reference NIR. So there's an NIR mean feature. There is also one for standard deviation NIR, and we can see there's some point cloud features that could reference NIR here. You can have the option of creating a new point cloud NIR feature here. And here, so also within the point fields, NIR is a point cloud field within eCognition, and you'll find that here. So you can simply come in and type this here. If, for example, I started to type area, this is a feature that is, or this is a name that is referenced in many different features. So I believe if it's referenced over 20 different times, then we don't do a breakdown within the tree and filter out to every one of these references. But as you did see, it does start to filter out some of the areas here. So I can come in, I see, okay, within object features, it's within geometry. Here also just within extent, bang, I can find this area feature quicker than, say, navigating through all the different parts of the tree. And I believe also, let me go back into one of our classification algorithms here. But when you're setting up a condition, for example, and you also reference with here from a feature, you can also search this list as well. So I can also type in near infrared and quickly jump to that feature, less clicking, less opening and closing, getting lost in some of the feature view menu here.
Okay, good. One last question. You've been working now in view setting 1, and the question is if now it's recommended to use view setting 1 for rule set development rather than view setting 4.
No, absolutely not. This is just an option to quickly get users into the project creation. View setting 1 has historically been the view setting used for project setup. So that's why we added this dialog here, but you can certainly go into the view setting 4, and then of course you see the number of windows, the window setup change based on things that are maybe more needed for the rule set development. So you can come in here and we just shift the view around a bit. You'll see then that by default my view settings is over here on the left hand side of my screen. I have a tab also where I can simply jump into the source view appearance, and in my process tree, my feature view, my image object information windows are open here. You can customize your view any way you want. You can remove menus, you can tuck them into and make them tabs like here. And if you do that, just click on view and save current view, and then that will be saved every time you open eCognition and go to your view setting 4. It will default to how you have set this up. By no means if should we not be doing development within view setting 1, but you have those just the default tools available there to you to accelerate the use.
Okay, that's it question-wise.
Excellent. So, if you're thinking about this, we have a few more slides to show, so you have some time to throw those questions out to us. And like Matthias said, if we finish the webinar and you realize, and then I had that question, you can always file your question afterwards, and I'll give you the address where you can best reach us with those questions in a few moments. So now taking the next step, for anybody that's new to eCognition, or maybe has just forgotten where to get additional information, whether you're looking for that eCognition textbook or just additional information, how can I accelerate my learning of this powerful software package? We have been hard at work generating more information and resources for you. So by default, you always get the user guide. So that's the user guide itself, the reference book, the release notes, which will go cover all new features and highlights, any bug fixes that may have occurred within the last release period. Those are all searchable and available through the HTML help. Very easy to access, or also delivered as a PDF to you on installation. Beyond that, there's the eCognition community that I mentioned earlier. So a lot of members in this community that are active. They're asking questions to one another, maybe uploading information, rule sets that they've worked on, exchanging information in various forms within this eCognition community. Support and training, always available. Matthias on the line here tonight is actually our main eCognition trainer, and is actually going to be flying out in a few weeks to do a training in Indonesia, if I'm not mistaken. So as you can see, we are bouncing all over the world to meet the needs of our customers, organizing open training events, and I really would advise you. I came from this perspective as an eCognition user. I really was able to accelerate my knowledge within the software by attending a training done by Trimble at the time. Also, eCognition support. Before you just get frustrated in looking for things, jot out an email to eCognition support. I'll throw that address up at the end of the presentation, and just ask us that question. There are no stupid questions, and you can save yourself a great deal of time if you just reach out to us. Beyond this, we've been very busy populating our YouTube channel. I'll show you that in a moment. We have blogs, we have webinars like this one. We try to do it on a monthly basis, so a lot of great resources available to you here. Our eCognition YouTube channel is now the home of our new monthly video series, and if you've ever wondered who is the great voice behind the eCognition Deconstructed videos, it's my colleague Matthias here tonight. So big thanks goes out to him for putting these videos together. These videos are really focused at going and looking and exploring various algorithms within eCognition. So like I said, we try and tackle this once a month. The last video we did, the October video, I looked at multi-resolution segmentation, taking this algorithm apart, explaining the parameters, and looking at how it can be used. So you'll find if you just Google Trimble eCognition or YouTube, you will be able to get to this channel. You're more than welcome to subscribe, and you'll get updated on our various videos that come out each month. So beyond that, we have eCognition blogs. These are currently hosted in LinkedIn. One is we have an eCognition group, so if you're a LinkedIn member, you can look for the group eCognition. And here we have what we call the eCognition Brainwave. This is a weekly tip of maybe just smaller things tucked into the software that you either forgot or never knew about. So you can see there are a lot of them available as it is weekly. You can comment on these, you can ask questions, you can say, hey, here's something I wanted to know. Here's a suggestion for the next brainwave. So you can reach out to us here as well. We also have a monthly newsletter, eCognition News, that is being put out on LinkedIn that covers a variety of topics, may announce a software release. It could be some great research or a use of the software that has caught our eye over the month. So you also find these articles there as well. eCognition case studies. So we're always looking for case studies that demonstrate what our users are doing with the software. These are available in the Trimble Geospatial Customer Stories page. You can Google Geospatial Customer Stories, find these downloadable PDFs where you can go in and see how some of our users have leveraged eCognition to tackle various data extraction or information extraction problems, and like I said, highlighting various customer experiences here. Oh, and of course, the webinars. We have a growing number of webinars now available as we do this on a monthly basis. The topics within our webinars varies from, say, a sort of a starting point, like this webinar today, introducing new software features and things of that nature, to power hours where we really dive into specific topics within eCognition. We also cooperate with those partner universities, which there was a question about earlier, on and doing presentations, and also working with some customers to present some of their work with eCognition. So you'll see here coral reef and seagrass habitat mapping. That was a great webinar series that we did with our partner university in Australia, the University of Queensland. Looking at the work they've done in this field, using eCognition for LiDAR point cloud quality control. This was done through the University of Vermont, another partner university of ours, looking at very specific use of eCognition for LiDAR data analysis. But you'll find a number of great topics here, and most important is, if you're not specifically interested in that analysis from a concept perspective, you can look at what other people are, how they are using eCognition, and extract those concepts that maybe you never thought about using a particular tool in eCognition in a particular way, and you can take that concept and adapt it to your particular use case. So you can join our webinars live if you have the time, but obviously register. They're recorded, and you'll get access to that recording after the fact. So. That wraps it up from my end. Big thank you goes out to Matthias for helping with the questions. But I guess before we close, finally, did any questions pop up in the last few minutes, Matthias?
Just one more question. If we're gonna have a training in the US next year, and maybe I can answer that. We're planning to host a training beginning on, let's say, in the first half of next year in the US. So if you want to get more information about the upcoming events, join our LinkedIn group. We're going to post these there, or write an email to our eCognition training address, which is eCognition_training@trimble.com, and we can put you on a list, and you get information about upcoming events, right? And that's about it. So no more questions for you, Keith?
Excellent. That being said, just again, thank you for your time this evening, at least our evening time here in Germany. If you have any questions that have come up that may have not been answered, or after the fact, you can certainly reach us at support@ecognition.com. Our support team will field your question and get back to you as soon as possible. This is the best way to get those questions answered. So I hope you enjoyed this webinar, and I hope you tune in to our future webinars as we move on with our software. So have a good evening, a good rest of your day, and thank you for attending.